Preparing for a Developer Advocate at MongoDB interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What does a Developer Advocate do at MongoDB? I view Developer Advocacy as a two-way technical bridge. My job would be to help developers succeed with MongoDB through demos, talks, documentation, workshops, and community support, while bringing honest product feedback back to engineering and product teams. Credibility matters, so I would explain trade-offs rather than oversell features. I would also measure whether my work improves learning, adoption, retention, or developer sentiment, not simply count views or event attendance. While answering, focus on connecting developers, product teams, and the broader community. Explain education, feedback loops, technical credibility, content creation, and the balance between advocacy and commercial objectives. Question 2. Why do you want to work as a developer advocate at MongoDB? MongoDB appeals to me because it combines a widely used developer platform with meaningful technical problems around data modeling, scalability, and cloud architecture. I enjoy turning complex concepts into useful examples that help people ship software confidently. The role also offers a strong feedback loop. I can learn from developers, create practical education, and help MongoDB understand real implementation pain. That combination of technology, teaching, and community impact is exactly where I do my best work. Make sure to cover MongoDB's developer-focused product ecosystem, your enthusiasm for teaching, relevant technical experience, community motivation, and how your values align with practical, trustworthy developer education. Question 3. How would you explain MongoDB to a developer who has only used relational databases? I would describe MongoDB as a document database that stores data in BSON documents rather than rows spread across fixed tables. The model often lets developers keep data that is accessed together in one document, reducing joins and simplifying application code. It still supports indexes, rich queries, aggregations, and multi-document transactions. I would emphasize that schema flexibility does not mean no design discipline. The access patterns should drive embedding, referencing, validation, and indexing decisions. In your answer, talk about documents, collections, flexible schemas, embedding versus referencing, query capability, transactions, and when MongoDB's model is advantageous rather than presenting it as universally superior. Question 4. How would you design a MongoDB schema for an e-commerce application? I would begin with the application's most important reads and writes, not with relational diagrams. An order document could embed line items because they are usually retrieved together and should preserve purchase time details such as price. Products, inventory, and customer profiles may remain separate because they change independently or grow differently. I would index customer and order identifiers, consider unique constraints, and test realistic workloads. The final design would reflect access patterns, document growth, and consistency requirements. Be sure to mention access pattern analysis, orders and line items, product references, customer data, embedding limits, denormalization, indexing, lifecycle requirements, and consistency decisions for operational workflows. Question 5. When would you embed documents versus reference them in MongoDB? I embed when related data is commonly read together, has bounded growth, and benefits from single document atomicity. For example, addresses or order line items can fit naturally inside a parent document. I reference when the related data is shared, independently updated, unbounded, or too large, such as products used across many orders. Duplication can be acceptable when it improves reads, but I would define which copy is authoritative and plan update behavior carefully. Focus on data locality, read patterns, update frequency, document growth, cardinality, duplication tolerance, atomicity, and the 16 megabyte document limit when explaining the trade-off. Question 6. How would you troubleshoot a slow MongoDB query? I would first reproduce the query with representative data and inspect its explain plan, especially whether it performs an efficient index scan or a collection scan. Then I would review predicates, sort requirements, index order, selectivity, returned fields, and document sizes. I would correlate findings with profiler data and server metrics, such as CPU, memory, and disk latency. After changing an index or query, I would benchmark realistic workloads and confirm write costs have not worsened. Make sure to cover reproducibility, explain plans, query shape, index selectivity, collection scans, sort stages, data volume, server metrics, profiling, and validating improvements under production-like workloads. Question 7. How do you decide which indexes to create in MongoDB? I start from frequent, latency-sensitive query shapes and examine their filters, sort order, and result size. For a compound index, I generally place equality fields first, followed by sort and range fields, while validating the rule with explain plans and benchmarks. I also consider whether a covered query is worthwhile. Every index adds storage and write maintenance, so I would monitor usage, remove redundant indexes, and revisit the design as workloads evolve. In your answer, discuss actual query shapes, equality sort range ordering, selectivity, compound indexes, covered queries, write overhead, storage cost, and ongoing monitoring rather than creating indexes speculatively. Question 8. What are MongoDB aggregation pipelines, and how would you teach them? An aggregation pipeline processes documents through ordered stages, with each stage filtering, reshaping, joining, grouping, or calculating results. I would teach it incrementally. Begin with match and project, add grouping and sorting, then introduce lookup or window-style analysis using a realistic dataset. I would explain how early filtering can reduce work and show the pipeline output after each step. Finally, I would discuss indexes, explain plans, readability, and when application side logic is clearer. Be sure to mention stage-based processing, filtering early, projections, grouping, lookups, explainability, realistic datasets, incremental demonstrations, and the difference between transformation logic and application code. Question 9. What is the difference between MongoDB transactions and single document atomicity? MongoDB guarantees atomicity for updates to a single document, which is one reason thoughtful embedding can simplify application design. Multi-document transactions extend atomic behavior across documents or collections when a workflow truly requires it, such as transferring funds between accounts. However, they introduce coordination, latency, and operational overhead. I would first model data so common changes remain single document operations, then use transactions sparingly with appropriate retries, timeouts, and write concerns. Focus on MongoDB's atomic single document operations, transaction use cases, performance and operational costs, retry behavior, write concerns, and designing documents to minimize unnecessary multi-document coordination. Question 10. How would you explain MongoDB's replication and high availability? A MongoDB replica set maintains multiple copies of data, with one primary accepting writes and eligible secondaries replicating the oplog. If the primary fails, an election can choose a new primary, improving availability. I would explain that durability and read behavior depend on write concern and read preference choices. I would also distinguish high availability from disaster recovery. Replicas help with failover, while backups, regional strategy, and restore testing address broader data loss scenarios. In your answer, talk about replica sets, primary and secondary members, elections, replication lag, read preferences, write concerns, failover testing, and the distinction between availability and disaster recovery. Question 11. What are MongoDB change streams, and when would you use them? Change streams let applications subscribe to data changes without directly tailing internal replication details. I might use them to trigger notifications, update a search index, synchronize downstream services, or build operational dashboards. I would filter events early, persist resume tokens, and design consumers to be idempotent because retries and duplicate processing must be expected. I would also explain availability requirements, ordering assumptions, error handling, and why change streams complement rather than replace a dedicated event platform. Make sure to cover real-time event consumption, replica set requirements, resume tokens, consumers, filtering, ID impotency, delivery expectations, and examples such as notifications, search synchronization, and event-driven services. Question 12. How would you create a technical demo for MongoDB Atlas? I would start with one audience and one practical problem, such as adding search and analytics to a small application. The demo should be reproducible, use safe credentials, seed realistic data, and show the shortest path from setup to working behavior. I would highlight Atlas capabilities only where they solve the problem, then include observability, security, and cleanup steps. A strong demo leaves viewers with runnable code, clear trade-offs, and a next experiment. Focus on a clear audience problem, minimal setup, realistic architecture, reproducible code, Atlas-specific value, security practices, failure handling, observability, and a concise path from demonstration to independent experimentation. Question 13. How would you respond to a developer who says MongoDB is not suitable for their workload? I would not respond defensively. I would ask about workload shape, consistency requirements, query patterns, scale, operational constraints, and the specific experience behind that conclusion. If MongoDB fits, I would demonstrate a design or benchmark tied to those requirements. If it does not, I would say so honestly and explain the boundary. Developer advocacy depends on trust. A thoughtful conversation is more valuable than forcing a product into an unsuitable architecture. In your answer, emphasize listening first, clarifying requirements, acknowledging limitations, asking about access patterns and constraints, offering evidence-based alternatives, and preserving trust even when MongoDB is not the best fit. Question 14. How do you measure the success of a developer advocacy program? I would use a balanced scorecard rather than one vanity metric. Leading indicators might include workshop completion, repository activity, documentation engagement, and quality of community questions. Later indicators could include successful prototypes, activation, retention, or influenced opportunities, while recognizing attribution is imperfect. I would pair analytics with developer interviews and feedback themes. The goal is to learn which activities change understanding or behavior, then invest more heavily in the channels producing durable value. Be sure to mention leading and lagging indicators, content engagement, qualified technical interactions, learning outcomes, adoption, retention, community health, attribution limits, and combining quantitative data with qualitative feedback. Question 15. Tell me about a time you explained a difficult technical concept to a non-expert audience. In a prior workshop, I explained event-driven systems to product managers who understood business workflows but not message brokers. I began with a familiar analogy, then mapped it to a simple order status demo and avoided unnecessary infrastructure terminology. I paused for questions and used a short exercise to check understanding. By the end, participants could identify asynchronous steps and failure points themselves. That experience reinforced that effective teaching starts with the audience's mental model. Focus on context, audience diagnosis, plain language framing, analogy or demonstration, checking understanding, adapting in real time, and a measurable result that proves the communication worked. Question 16. How would you handle a technical error in a live MongoDB presentation? I would acknowledge the failure plainly rather than pretend it did not happen. I would first check whether the issue is environmental, such as credentials, network access, or stale data, and keep the audience engaged by explaining the expected behavior. If recovery takes too long, I would switch to a tested recording or fallback dataset. Afterwards, I would reproduce the issue, correct the materials, and share an accurate follow-up instead of leaving confusion behind. In your answer, discuss staying calm, acknowledging the issue, protecting audience trust, diagnosing visibly but efficiently, using fallback materials, separating demo failure from product behavior, and documenting follow-up. Question 17. How do you keep your MongoDB technical knowledge current? I use a deliberate mix of reading and building. I follow MongoDB release notes, documentation, engineering posts, and relevant standards, then validate important changes with small experiments. I also learn from support questions and community discussions because they reveal where documentation or mental models break down. Before presenting a feature, I test its behavior, limitations, and operational implications. That habit helps me teach current, accurate guidance rather than repeat assumptions. Make sure to cover release notes, documentation, source code or technical blogs, hands-on testing, community conversations, production feedback, structured learning, and validating claims before presenting them publicly. Question 18. How would you write a developer tutorial that people can actually complete? I would define one measurable learning outcome and remove anything that does not support it. The tutorial would state prerequisites, provide a clean starting point, use copyable code, show expected outputs, and explain why each step matters. I would test it from a fresh environment, including failure paths and cleanup. I would also add checkpoints and an optional next step. Completion matters more than clever prose, so I would use reader feedback to refine friction points. Focus on a defined learning objective, prerequisites, progressive steps, runnable code, expected outputs, troubleshooting, version control, validation by fresh users, and a clear extension path after completion. Question 19. How would you collaborate with product and engineering teams when community feedback is negative? I would collect specific examples, affected workflows, frequency, and business impact instead of forwarding a general complaint. I would separate usability issues, documentation gaps, bugs, and feature requests, then share evidence with the relevant teams. I would avoid promising timelines I cannot control, but I would keep the community informed about what was understood and what action followed. This approach turns criticism into product insight while preserving credibility on both sides. Be sure to mention separating signal from anecdote, documenting reproducible evidence, prioritizing user impact, avoiding blame, communicating trade-offs, closing the feedback loop, and protecting community trust throughout the process. Question 20. What would your first 90 days as a MongoDB Developer Advocate look like? During the first month, I would learn the product deeply, review existing content, meet engineering and community stakeholders, and listen to developers through forums or events. In the second month, I would identify a recurring pain point and build a small, tested tutorial or demo around it. By the third, I would publish, gather feedback, and measure completion and engagement. I would use those results to propose a focused advocacy roadmap grounded in evidence. In your answer, outline listening and product immersion, community and stakeholder mapping, hands-on technical validation, an early content experiment, measurable goals, feedback loops, and a realistic plan to deliver value quickly. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.